If you've ever wanted to become an environment artist, well, now's your chance. Introducing the brand new Environment Artist Survival Kit, a brand new course designed to take you from a complete beginner to an absolute master in Unreal Engine. You're going to be creating everything you see on the screen here. Pretty amazing, isn't it? Now, early bird pricing is just starting. The course has just dropped. So if you want to get the course at a reduced price, hop on right now and grab it before it's too late. Let's get into the video.
Hey people, my name is Hasan and I'm a 3D artist from the Netherlands. I've been invited by Artstation to walk you through my creative and technical process for this prop. During this video I'll be going over my planning phase, how I choose to set up my reference, how I block out my model, how I create my high and low poly from there, and finally how I choose to texture and render my prop before posting it online. My workflow during this video will include Blender, Substance 3D Painter, Substance Designer, Marmoset Toolbag and Photoshop, though any image editing software will do. First up comes the planning stage. During this stage I like to set some restraints for myself to establish a direction for my project. I usually do this by asking myself a couple of questions based on what I want to make. In my case I knew that I wanted to model something complex to push my poly modeling skills. Gathering reference is something you keep coming back to throughout the entirety of your project. So I like to keep things simple at the beginning. I start out by looking for images of various angles, front, side, top and bottom view. If you're working from an existing concept or product, like I am, you can usually find some nice orthographic reference. Then I like to line up my reference in a PureRef board, but you can use whatever works for you. Once I have my reference board set up, I can boot up Blender. First thing I like to do is import an image of my side view. I do this by just dragging in an image from my file explorer. One thing to keep in mind with this method is that you can't enter edit mode with this image, and it will be displayed as an image regardless of your viewport mode. After that I add a box and scale it down to match the dimensions of my prop, which I found online. It's not exactly a one-to-one scale since there is some white space in my image, but it's close enough to get me started. I also don't want to accidentally click on my reference while I'm editing, so I'll add a restriction to it through my inspector. With my reference placed, we can start blocking out our model. I'll try to recreate the handle of my gun for this example. I want to make sure my model is pretty low poly right now to keep it easier to manage. Going too high, too early, means that it'll be harder to bring in big proportional changes if something turns out to be wrong later on. I'm also trying to be as non-destructive as possible. I do this through the use of modifiers. Modifiers change the way your model is displayed without actually affecting the geometry, which means that we can keep editing them as long as we don't apply them. My handle here has two sides which are largely the same, so I apply a mirror modifier, which means I only have to model one side for now. Two important things you should know when working with modifiers: that first of all, your modifiers take into consideration your object scale, location, and rotation. This can break your modifiers if you're not careful. And the second thing is that the order of modifiers does matter. You can stack more than one modifier, and their order in the modifier stack changes how they affect your model. If you choose to subdivide your mesh and then bevel it, you get a different result than if you beveled before subdividing. Once I'm happy with where my blockout is, I'll make a backup of it and move on to my high poly model. We can use this high poly to generate various textures such as normal maps and ambient occlusion. These textures allow us to create the illusion of a higher fidelity mesh while having an optimized low poly model. And they're very useful for the texturing stage, as it will allow us to work with generators and filters within Substance Painter. I'll be using the Subdivision Surface modifier to create my high poly. Subdivision, or sub-D for short, takes existing geometry and splits them into smaller faces. Do this enough times and you get a smooth high poly mesh. But we'll need to set up control loops in order to control how much each area of our mesh gets softened. I'll start off by adding a smooth by angle modifier to my mesh and setting its angle to 60 degrees. In edit mode, I'll select everything and choose to shade it smooth. Then I'll apply my auto smooth modifier. This creates hard edges we can automatically grab later. In the modifiers tab, I'll add a bevel and sub-D modifier, make sure that your model bevels before it subdivides. In the settings of the bevel modifier, I'll change the amount of beveling to 2. And in the profile settings, I'll set the shape to 1. This makes it so that our bevel doesn't really bevel anything, but rather sticks to the form, thus creating our support loops. Change the limit method from angle to weight. Now, I'll click on a hard edge and use the Select Similar menu to choose Sharpness. This should choose all hard edges. Set their bevel weights to 1. This gives us a pretty good base to work off of. I'll select the rest of the edges I want beveled and set their weights manually as well. You might notice that the beveling is pretty small overall. This is because Blender by default clamps overlap when beveling. It also means that there's an area that's getting beveled, which is pretty tight. So I'll have to manually find it and smooth it out later. But for now, I'll just disable the clamp overlap and see if there's anything that sticks out. We'll be using a boolean for the pill-shaped indent on the cylinder. Booleans are tricky because they give you a lot of flexibility since they're non-destructive and can easily create some very complex forms. But on the other hand, you'll have to manually clean up a lot of it if you want to use them with sub-D, and they will absolutely demolish your clean topology. First, I'll create a circle and delete half of it. Then I'll extend that circle and mirror it to create my pill shape. In the modifier settings of the handle, click on Boolean and set the pill as its target. If you hide the pill, you can see that it's creating an indent. Now I need to clean up the area around the boolean to make sure it subdivides properly. First, I'll apply my boolean modifier so that it becomes actual topology. I'll create a loop around the pill shape. Then I'll triangulate the flat area to make sure there are no n-gons, which would otherwise break our subdivision. Once I'm happy with my high poly, I'll make a backup of it. I'll be using a free add-on called Loop Tools while making my low poly, so I'll first go and enable that. It should be included in my version of Blender, so I can just go to Preferences, Add-ons, and enable it from there. If you're working with a version of Blender which has the extension manager, you might have to get Loop Tools from there instead. Back to our low poly. Since we've worked pretty non-destructively so far, we can easily extract a decent low poly from the high. I'll start by removing the subdivision and bevel modifiers. Then I'll delete the indent on the cylinder because I want that to be baked in, and not as actual topology. I'm noticing that my cylinder is pretty faceted, so I want to smooth it out by adding more topology. Select the loops, bring up the edge menu with Ctrl E and select Subdivide. Then right-click and in Loop Tools click on Circle. This should smooth it out. Then I'll add extra topology to the other areas, which are pretty faceted. You might notice that instead of creating new, full loops, I'm starting to converge the polygons into triangles. The reason for this is that I don't need these loops to go all the way to the other side. So, to save on poly count, I merge everything at the first flat surface I can find. These areas are surrounded by hard edges and don't curve. So, adding triangles here won't create any ugly shading. The trade-off is that if I want to deform this mesh, during an animation for example, I'd have a pretty hard time controlling it. Because I don't have clean uniform topology anymore. Now we can move on to our UVs. UV maps are what we get when we project our 3D model onto a 2D image. It's kinda like flattening a box or unfolding an origami. These 2D images are what we'll actually be painting on when we're at the texturing stage. The reason we do this last is because our UVs get changed whenever we edit our model, so your model should be pretty much done at this stage. We make our UVs by creating seams on our mesh. These seams are areas where the 2D image will actually be sewn onto our 3D model. We then unfold our model into a 2D UV island. I've thrown on a checkerboard texture on this model so we can actually see the effect our seams have. The first cube here has decent UVs, so our checkerboards don't distort or disform in any weird areas. On the second cube, I've added extra loops and moved those loops after UVing. And on the third cube, I've removed some of the seams, which creates some pretty heavy distortion because the UV islands are stretching in weird ways. Back to our model. I'll start by creating a checkerboard material so we can see if our UVs are stretching. Go to the Materials tab and create a new material. Then go to the Shading tab at the top. Here I'll press Shift A and search for Image Texture. Click on New and select UV Grid. Plug this into your base color. Now go to the UV Editing tab, and here we want to change the viewport to Material Preview. We do this by holding Z and selecting Material Preview. Here we can start making our seams. First, we want to turn all of our hard edges into a seam. If our hard edges don't have seams on them, we'll have artifacts on them during our bake. It also gives us a really good base UV to work with. After that, I'll apply my mirror modifier. I'll also quickly check whether my object scale is set to 1, because unwrapping with a non-uniform scale will stretch out our UVs. If it's not at 1, I'll press Ctrl A to bring up apply and then I'll hit scale. Alright, we have our base UVs, but I can see that a lot of space is being wasted by some of our more curved lines. We want to use as much of the UV space as we can. I'll be turning some of these UV islands into straight lines to save some space. First up, I'll disable the UV sink in the corner again. We'll be working with individual UVs, and having UV sink on might stretch edges we don't really want to touch. Then I'll go to my viewport and press A to select all. In my UV, I'll select the UV islands I want to straighten out. This includes the curved lines, cylinders and the large area of the handle. Pressing Shift H will hide everything we haven't selected. Don't worry, because we can always get these back by pressing Alt H later. Now I can go to each island and straighten them out. I'll select an individual face and make a rectangle of it by straightening each side. I do this by pressing S to scale, choosing an axis such as Y or X, then pressing 0. This creates a straight line out of the vertices I have selected. Click on the rectangle and press L to select everything linked to it. Then hit F3 to bring up a search bar. There, type in follow active quads. Hit enter and you can see that we now have a straight UV strip. This method only works if you have clean topology though. If you have any triangles or n-gons, you'll have to manually stitch those back in. I do this by enabling snapping at the top and changing the snapping mode from increment to vertex. Then I just bring the vertices back to where they were originally connected. Another benefit to having straight UVs is that when you're trying to texture something that has a pattern to follow, like wood grain or bricks, it's easier to place them since they just follow a straight line. When I have all my UVs straightened out, I'll want to pack them for the export, but I've played around with the scaling of my islands while I was straightening things out. We want our islands to be about the same size. I'll hit F3 and search for average island scale. Then I'll hit F3 again and search for pack islands. This will pack all of our UV islands into one tidy image. After I did this though, I noticed there was still some UV space to be gained, so I quickly add some extra seams to my mesh and repack it afterwards. With our UVs done, we can export our mesh and bake it in Marmoset. First, we want to make sure that our low and high poly share the same name. Then we want to add lowercase low to the end of our low poly and lowercase high for the high poly. This will allow Marmoset to automatically set up a bake group. Then I'll just double check to see whether all my transformations have been applied. Now I'll select both my low and high poly and export them. I'll go to File, Export FBX. I don't want to export everything in my scene, so I'll limit my export to selected objects only. Then I'll select Mesh to make sure I'm only exporting my mesh. Now we just bring our model into Marmoset for our bake. I'll click on this bread icon to add a bake project. Then I'll click on the quick loader and select my file. Click on the preview icon for our bake. Since we haven't selected a path, it should ask us where we want to save. Once we have our path selected, we should be able to see a preview of our normal map. I can see that my indent is a bit skewed, so I'll click on my mesh and click on Paint Skew. Then I'll go over the skewed areas with my brush. This should correct it. I'll do the same thing to the other side. Now that I know my bake works, I'll select the rest of the maps I need. In the bake project, I'll click on Object Normals, Curvature, Ambient Occlusion and Material ID. Now we're ready to start painting our texture. First, I'll export my low poly from Blender. Then I'll boot up Substance 3D Painter. Go to File, click on New. A new window should pop up. Click on File. In the Explorer, find where you've placed your low poly. Now we select a template for our project. This affects two things. First of all, depending on the engine you're working in, your normals will usually be set up for use with either OpenGL or DirectX. If you're trying to use an OpenGL normal map within a DirectX project, your normals will be inverted. You can fix this by flipping the green channel in the RGB channels of your normal map. You can choose to do this in either Substance Painter or the program you create your map in. And the other thing is that this also affects the texture packing Substance Painter will use when exporting your textures. Texture packing is a way to optimize texture memory by packing multiple textures into the individual RGB or alpha channels of a single image. Unity and Unreal both have their own preferred way to pack textures, which you can find in their documentation. And you can always change how you want to pack your textures on Substance Painter export settings as well. Let's pick a texture resolution now. I'll go for 4K since this is just an example. I also like to work with higher resolution textures since I can always downsize during my export anyway. With everything set up, click on OK. Now that we're in our viewport, let's import the maps we've baked in Marmoset. We do this by just dragging them in from our file explorer. I click and drag my mouse over the files and tag them as textures. After that, I'll toggle it so that my textures save to my project file and not my entire library. Now I'll click on the texture set settings and start assigning my textures to the right slots. There's also one more map I like to use in Painter itself, which doesn't need a high poly, and that's the position map. We use the position map to generate gradients. I'll go to Mode and click on Bake Mesh Maps. This will open the Substance Painter Baker, where you can also bake your maps, if you don't want to use Marmoset. I'll disable all bake textures here, except for position, then click on Bake Selected Textures. Return to painting mode by clicking the button. And that's pretty much how I set up everything until the stage. Now I'll go back to my main file to show you how I've textured my Nerf gun. Before I start texturing, I'll create a small breakdown of the materials I'll have to make. Alright, when I look at the main body of my Nerf gun here, I can see that there are two types of plastic on it. A glossy blue and orange. I can see that there are normal details on it which I also haven't baked in. Things such as the logos and the diamond-shaped knurling on the grip. My Nerf gun is not brand new, so I'll have to create surface imperfections such as scratch paint, dirt and grunge. And finally there's the grip, which looks like it has a matte rubber-type paint sprayed on top of it. This list is enough for me to get started with texturing. I'll gather the reference I need and start building them up layer by layer. The way I do this in Substance Painter is through the use of fill and regular layers. When working with layers, you can paint anywhere you want right off the bat. You can also adjust individual channels such as base color, roughness or metallic by just changing your brush settings. But once you put your brush strokes down, they're pretty final. You can still edit them through filters or levels, but it's harder to lock down individual elements like a specific color. With fill layers, on the other hand, you'll fill your entire material with the parameters you choose, but you can easily change these parameters whenever you want. However, if you want to add something like an extra color, you'd have to create a new fill layer. You also can't just paint when using this layer, so you usually do this by masking your mesh and painting on your mask instead. This is my preferred way of working, because I can keep coming back to adjust my layers to whatever I needed. And I'll usually add a normal layer by the end of it to hand paint some details anyway. Alright, let's start going through my layer stack now. For my logos here, I created a mask within Photoshop, where my logo is pure white and everything around it is black. Then I import that mask into Painter. Here I create a fill layer, set it to height only and move up the slider. Right click on my fill layer and add a black mask. Right click again and select fill. Drag your logo onto the box that says grayscale. You should see your logo now, but it's getting repeated everywhere. Click on UV wrap and select none. Now I can place my logo wherever I want it. Now I'll add a blur filter to it to remove the sharpness a little bit. Right click on my mask and select filter. Click on filter and select blur. Adjust to the sharpness you need. For the indent lines, I create another fill layer and set it to height only again. I'll create a black mask and create a paint layer. Then I'll paint wherever I need my indent to be. This goes through my logo though, and I don't want that. I could manually paint out the overlap, but then I'd have to repaint that if I ever moved my logo. So what I'll do is use something called an anchor point. Anchor points allow you to grab elements from layers that come from before it and use them somewhere else. So in our case, we can take the mask of our logo and use it to erase parts of our indent here. For this, I'll right click on the mask of my logo and click on anchor point. Now I'll right click on my handle lines mask and add a fill. In the fill, select your anchor point. Set the layer type to multiply. If we move our logo now, we can see that it automatically masks the area where there is overlap. For my diamond knurling, I've created a simple pattern in Substance Designer. I did this by creating a shape and rotating it 45 degrees. Then I beveled it and repeated the pattern with a tile sampler before smoothing it all with a blur filter. From there, I generate the extra maps I need and import them into Painter again. Now that my extra height and normals are done, I can focus on my base color and roughness. Roughness simulates how smooth a surface is, with 1 being very rough and dull and 0 being very smooth and reflective. It's important that we have a nice variation in our roughness, because it'll make our materials pop more when we're rendering them. I'll start with a fill layer and change it so it has a blue color and low roughness. Then I'll duplicate that layer and slightly change the color and roughness for variation. Then I'll create a black mask and add a fill. For the fill, I'll select a grunge map, which looks interesting. Now I'll change my viewport to mask so I can better see what my mask is doing. I can see the seams on my edges there, so I'll smooth that out with a generator. Generators take the maps we've baked with our high poly and use that to generate a mask or material. So they're really useful if you need to set up a dynamic mask you can adjust. I'll recreate this generator here to show you. Right click on your mask and click on generator. I'll select the mask editor. It's masking a bit more than I'd like, so I'm going to reduce the intensity by going to curvature and moving around the sliders. Now I'll change the layer mode to lighten to bring back my grunge map. I'll lower the layer opacity to something like 40% to blend it in better. I'll add a slope blur filter and levels to adjust it. I'll also lower the intensity of the layer as a whole so it's not too intense. Now I want to add some scratches under my gun, because I think that's the area that would touch the ground the most and probably get scratched. So I'll create a fill layer with a light gray color, high roughness, and just a little bit of negative height. Then I'll add a mask and fill it with a grunge map. It's pretty intense right now, so I'll balance it with levels. It's also pretty evenly spread out, but I only want it to be under my gun, so I'll use the position map we baked a while ago. Right click and add a generator. Here I'll select the 3D linear gradient. Set the layer to multiply. Then in my display I'll go to my position map. Click on the color picker on position start and select where you want your gradient to start. Same thing for position end, but for where you want it to end. Play with the balance and contrast for the settings you need and add a paint layer and hand paint it a little bit. For my screws, I just used a fill layer with a base color, roughness and a metallic. I baked these screws in with my high poly, so in my case I also had an ID map to mask them with. What I did was right click and click on Add Mask with Color Selection. In color selection, click on Pick Color. This shows you the ID map of your texture. If you click on a color here, it'll automatically mask everything with that color it can find, which in my case covered all of my screws. Now for my logo. For my logo color, I created an orange fill layer and added a black mask. Then I filled the mask with an anchor point I created earlier. In another layer for scratches and damage, I multiplied my mask with an anchor point so I wouldn't be able to paint outside of it. Then I hand painted the damage in there. For the dirt around it, I added a generator. However, the maps we've baked didn't have our logo in it. Generators normally won't take this kind of detail into account and treat this area like it's flat. To change this, we'll be using something called micro details. Through micro details, we can use generators on areas where we would normally need things like curvature maps. I'll do this by going down into my generator settings and enabling micro details. The logo I've placed uses a height and not a normal map, so in my case I just need to enable micro height. Then I'll go down to my settings and assign my logo's anchor point to my micro height. Then I multiply the generator with my anchor point again, because I only want this dirt around my logo. After that, I'll put in some hand-painted details for some variation. The grip of my gun consists of two different parts, the blue and the dark gray. For my blue part, I put on a rubber grip material and disable everything except for the roughness and normal. In this case, I create an anchor point in the material instead of on the mask like I normally would. This is because I want to use the roughness map of my material as a mask. I also set up my mask so it only affects the blue handle. To add color to my indents, I'll create another fill layer and add a black mask. I'll fill the mask with the anchor point of my previous material. Then I'll select the roughness as the reference channel. The reason I do this is that the indents of most materials are also where most dust and grunge gathers, so they would show up as white in our roughness map, which is perfect since we want to use that area as a mask. Then I'll multiply my mask with another anchor point to limit it to this area. In my color layer, I'll add a fill and choose something with some nice variation. Then I'll add a filter and select gradient. Here I can add some color variation to my grayscale by assigning colors. I repeat this process for the gray part of my handle. After that, I use all of the techniques I've showed so far to add some extra dirt and directional damage to my gun, mostly starting out with generators but then mixing things up with multiple layers and hand-painted touches. While hand painting, I'll also use custom stencils and alphas. I usually generate these from images I find on the internet or make them from pictures I take myself. They are a great way to add some shape variation to your textures. Here's an example of one of the torn paper stencils I've made using my own photos. I wanted to show the fibers you see underneath when you usually tear off a sticker. To get that variation, I took some paper and put some duct tape on it. Then I ripped off the duct tape and took pictures of the fibers I could see afterwards. I placed these in Photoshop and turned them into black and white alphas to use in my project. If I hover over this area with my custom stencil, you can still see the shape it tore out of my sticker. For the finishing touches, I like to try and add some storytelling elements. I already tried to do that here by adding custom attachments, but I'll also try to bring some of it back in my textures. Like maybe this gun was owned by someone else. To show that, I'll add a torn off price tag and a wipe name. Maybe the current owner likes cartoons, so I'll also add some stickers to show that they do. I might add fingerprints or other damage on the grip, where the gun would be touched often. These are all small elements individually, but together they can really bring your texture to life. With this done, I'll export everything and start setting it up in Marmoset. I do this by going to File, Export Textures. Here, I'll select my output directory and how I want my textures to be exported. In my case, I'll just go for the document channels since I won't be using these in a game. I'll set my texture size, click on the textures I need and click on Export. Before I even launch Marmoset, I like to look for reference on the kind of lighting I'll be using for my render. In my case, I know that I want to use something like studio lighting for a nice strong contrast on my first shot. For my other renders, I'll try to bring some storytelling back into them, so I'll also look for store shelf setups so I can create a render of my gun while it's in a store. Now for the setup. With Marmoset open, I'll just drag in my model. If you've assigned materials to it, you should see them pop up in your corner. Drag the correct textures to their slots in each material. For additional maps you might want to use, such as emission, ambient occlusion, or subsurface scattering, you'll have to enable them manually in your material settings. Now let's set our background and select the HDRI. What the HDRI does, it affects the overall lighting in our scene. So if I chose an HDRI that's set in a studio, I'd get way different lighting compared to one of the evening sky, for example. For my studio lighting, I'll try to look for something pretty diffuse, since I'll be using a lot of custom lights myself. I'll adjust the brightness of my HDRI and set my backdrop mode to color, because I don't really like the gradient it's currently using. Then I'll go to my camera settings. Under tone mapping, I'll change it from linear to aces. This has a pretty big impact on our contrast and saturation and will make our work look more photorealistic. There's a bunch of other post-processing effects here, but we'll go over them later. Now I'll look for the angle I want to use for my render. Duplicate the camera and on the old one click on Save Frame and lock it in place through this tiny lock icon. I use this system whenever I'm rendering so that I'll always have one camera locked on how I want to render and another to use in my scene. Now I'll go to my main scene and give you a breakdown of my lighting. Here we are. First things first, I'll create a directional light for my main light. With this light, I'm trying to create interesting shadows, so I'll usually move it around a bit until I can find a nice balance of light and dark. The color and intensity of this light is also fairly neutral, because I'll be going around each individual area once my main lights are set up, and I don't want my lighting to already look overblown at this early stage. Once I'm happy with how my shadows look, I'll create a second, weaker directional light to lighten them up a little bit. Then I'll create a spotlight for my main highlight. I want to use this light to create my main focus area. In my case, this is around the front to middle area. I'll adjust my spot angle and lower the sharpness, so it'll create a nice smooth gradient. Now I'll get started on my main rim light. These lights come from the back and are usually very strong to help us create a nice silhouette. I'll set this light up to be pretty intense at first so I can better see the effect it has. Then I'll adjust its brightness once I like where it's at. I'll also start using more colored lights from now on. If I only keep using white light, I'll end up with a pretty desaturated look, which I don't really want. And that's pretty much it for my larger lights. Now I'll go to each individual area and create additional colored lights. These are there to help push my color and create interesting shapes. For this, I'll either use more spotlights or start using omnidirectional lights. It's probably also worth mentioning that the way I'm using lights here is definitely not performance friendly. But we can get away with it here because it's an individual prop and a portfolio render. This is the point where I'll usually go back to my camera for my post-processing. First, under tone mapping, I'll try to create more contrast by playing with the settings there. I can do this with the sliders that are present or through the curves button. Then I'll sharpen my image. You have to be careful here because if you overdo it, your image will end up looking deep fried. Personally, I'm not a big fan of bloom, so I won't be using it. But I'll be adding a small vignette because it creates a focus area. For my final settings, I'll go to my render options. I'll usually start by increasing the quality of my shadows. Then I'll enable ambient occlusion, if there's any model in my scene that doesn't have an AO map. Under the Reflections tab, I'll enable both reflections and local diffuse. Local diffuse is really important if you want that smooth, bounced light effect. And last but not least, select the output directory you want and select the resolution for your render. If you want additional renders, such as your wireframe or normals, you can go down to Render Passes and add them just by clicking on Add New. When you have everything selected, go to Render and click on All Images. Alright, that's pretty much everything. There's still a lot I wanted to go over, but this video is already a pretty huge info dump, so I'll just leave it at that. It's also the first time I've made a video of this length, so I hope it's been useful to you. And if it has, please check out my Artstation, where I'll be posting more of my stuff soon. Right now I'm working on a mechanical arm and another more stylized project, which I'll hopefully be posting soon-ish. Probably not, but you know.